Okay, Chapter 3, Orbiting Bodies. Welcome to part 3 of my hypothesis of gravitation. Previously, we explored the two-body system. Here we'll be looking into orbiting bodies. It should be a nice and quick chapter, so let's just get into it. As I've shared, there's a couple ways I picture things. So far, I've been using this image as the main focus, where the blue line represents the density of space, but they can also be expressed as gravitational field lines. I also shared these pictures briefly in a previous video, demonstrating the density. Here is another way I like to picture things, with the mass shown at the center and the gravitational density expressed outwards like so. The circles, rings, spirals represent the strength of the pressure density, with tighter rings the closer to the mass and more spaced out rings the further out. Now we can go another step and show in terms of the space-time field in what I call gravitational field lines expressed in one dimension. And this might look something like this. These lines represent the gravitational strength due to space-time density. The further away from the straight line they are, the stronger they are. I still don't know if this is a good way to picture it, but it helps show how this affects other aspects of the hypothesis. As long as you always keep in mind this is due to the density of space field itself, then it should help. Sorry for this bit of rambling. Personally, it helps me picture things in different ways, which can help solve or reveal problems, so I thought I would share it as well. Using the two-body system, I can show how this would look for the different visual cues I just suggested. This figure here shows two unbound masses that do not interact, and the bottom shows the masses close together, where they are now bound and will be drawn together. And using a directional plane, we can express an orbiting frame like so. Really, this is very similar to Einstein's curved space images we often see, but instead of dips where mass bends space, we have intensity, I guess. Without orbiting mechanics, the masses will be drawn together in a straight line due to the line of sight cancelling of forces. But if we add motion to the smaller mass and use the gravitational field plane to see its effects, we get this image here. The gravitational field lines are curving around a central mass star that is just out of frame on the left. These lines are being pushed away from both present masses, the mass shown in this drawing and a dominant mass out of frame. This results in gravitational pressure around the masses that decreases with distance. The secondary mass kind of catches between the warping field lines caused by the main mass, further warping said field in a localized region. These altered field lines produce a strange pattern, no longer neatly stretched from a single body, but instead pushed and pulled between the two bodies. Each vector is a force acting on the mass. V1 is the direction of velocity. V2 is the total pressure from outside the small mass, pushing the body towards the central mass, as we explored in the previous video. V3 is the counter pressure, pushing outwards from the balancing point at the Lagrange point. And V4 is the built-up gravitational pressure caused by the orbiting mass. I'm not sure if this V4 option exists. In coming chapters, we'll explore possible variations in density that might result in this, so I've kept it in, but it's probably not a thing. Adding these together, we get the overall directional vector of the smaller mass. This results in the smaller mass orbiting the larger. The smaller mass needs to be traveling at a specific velocity at a specific distance to remain in orbit. So this ties in well with what we expect with orbiting bodies. And body problems, a quick dive. The orbiting behavior plus our line of sight gravitational density behavior would also explain orbiting resonances and unstable orbits. When an object falls within the line of sight between, say, the Sun and another planet, that suddenly alters the cancelling out effect it had with its line of sight with the Sun. The picture is suddenly more complicated. The line of sight density suddenly goes from two independent positions to three, the two on the outermost side of the outer bodies and the one between the inner body. So suddenly this middle body is no longer experiencing the higher gravitational pressure from the outside it usually always experiences when dealing with the two-body gravitational density. A large chunk of the outer pressure has been cut off, and for a brief point in time, while all bodies are aligned, the middle body is experiencing different effects dependent on the mass and location of the third outer body. Regardless, the middle body will receive a kick of apparent energy, and depending on strength and regularity of this third body alignment, the kick can completely change the orbit or help stabilize the middle body. Yeah, so that's it for that chapter. Like I said, very short. The next one will probably be a bit bloated.